This is the first video on Chapter 26, Derivatives of Algebraic Functions. And the first thing we're going to look at is the power rule. Power rule is one of the favorite theorems generally of calculus students, because after taking the derivative using the definition of derivative and all of those limits of indeterminate forms type 0 over 0 that we have to simplify, now we have faster ways of calculating the derivatives. And so the derivative of x to the n, x to an exponent, is the exponent times x to the exponent minus 1. The proof that's given in the notes is for n being a natural number. And there are a couple of different proofs for that. One uses induction. That's not the one that I put in the notes. The one that I put in the notes uses the binomial formula. And so, for example, if f of x is x cubed, then the derivative is 3 times x to the 3 minus 1. So we just have 3x squared. Now, even though the proof in the notes is for when n's a natural number, it's true for all real numbers. So, for example, if g of x is x to the 1/2 power, which we can write the square root of x is x to the 1/2. So if g of x is x to the 1/2, the derivative of g is 1/2 x to the negative 1/2. So we just use the power rule. Multiply by 1/2, then we have 1/2 minus 1. And then we can rewrite that as 1 divided by 2 times the square root of x. Exponents don't have to be nice. We can have x to the pi. The derivative is going to be pi times x to the pi minus 1. And so that's what these three examples have in common. Now, while I'm talking about x to the pi, I want to mention that pi to the x is an entirely different animal. So this is a different type of function, and this is what we call an exponential function. And calculating the derivatives of exponential functions is something that we do in Calculus 2. So this is a Calc 2 problem.